Hello, my name is Albert Chang. I am going to give you a quick demo of how you can use VMware Blockchain to build an ERC-721 NFT exchange. What would you do with an NFT exchange anyways? Here is a quick use case overview. Alice on the left is an inspiring poet and she has the wherewithal to create a digital art as seen above, to be or not to be. She wants to be able to tokenize this into a digital asset format and then be able to put it on the exchange and be able to trade it or sell it. So on the right-hand side here, we have built an NFT exchange for Alice to do so. The blue solid box in the middle is the NFT exchange platform that provides a RESTful interface for the dApps on the upper side. The NFT exchange is running on a Spring framework, which is a popular Java-based framework used by enterprises. At the bottom, we see VMware Blockchain running as the blockchain network that's underpinning the Spring-driven NFT exchange. And at the upper half of the right screen, where Alice, Bob, and Charles are, the NFT exchange provides a RESTful interface for the dApps so then Alice can deploy a contract, mint her asset, and then transfer her poem from her to Bob. And then Bob then can check his balance to see that the asset did indeed transfer so that now he owns the asset. Okay, now let's go through a quick demo walkthrough. The next step is to start VMware Blockchain running locally on my MacBook Pro. We have containerized VMware Blockchain so it can conveniently run on any Dockerized environment such as Kubernetes. In this particular case, I'm running on Docker Desktop. Let's use Docker Compose to read in the YAML file to bring up. Okay, now that Docker Compose is done, let's take a look and look at the Docker processes that are running. And we can see that indeed VMware Blockchain is now started and running on my local environment. Good. Let's now take a look at the front end for the exchange. It is built on Spring, which is a Java framework used by many enterprises. Here on top, you'll see imports for the Spring framework. And then more interestingly, the second portion here is imports for the Web3j. This is imported from Web3 Labs, which is necessary for the Spring framework to work with the smart contracts. Let's go over the code here quickly. Here you can see standard annotations from the Spring framework. We have our main class, which is called demo application. Here you can see we are instantiating Web3 objects that allows for connection to the blockchain network. We created 3 temporary credentials for the demo. And then here's the main, which launches the Spring application. Over here, we can see the mapping of several RESTful interfaces needed to interact with the smart contract. For example, here we have a get mapping at Mint that goes ahead and instantiates a Web3 object called Transaction Manager. And in it, it will interface with the local contract so that the contract can be invoked to mint the digital asset. The second class of interest is the digital art. This is auto-created from Web3j, which is reading in the truffle output as JSON. So if you take a look at here, you can see the actual binary code, and its long string that is actually imported from the output of the Solidity code compile, which can be from either Remix or Truffle. Speaking of Remix and Truffle, let's take a look at them. Now let's go over quickly Remix, which is a web browser-based IDE to create and compile Ethereum Solidity smart contract code. We have a normal web browser. In this case, this is Chrome. We're pointing to remix.ethereum.org. And here in this workspace, I call VMBC NFT, I have created a new contract called digitalart.sol, standing for Solidity. Here, I have imported OpenZepplin, which provides basic template and code for ERC-721, and we can use that and then fill in the rest here with code that we need to implement our NFC exchange. Once we have completed the smart contract, we can go ahead now and compile, and we can see that compile finishes with no error. So we have a good working smart contract code. We also want to show how we support other standard Ethereum tooling, such as Truffle. So first, let's start in this directory, which is a standard Truffle directory. You can see that we have build contracts and the truffle config.js. So if we more contracts, this is the same Solidity code that was shown earlier through Remix. So let's go ahead and compile this through Truffle. And voila, you can see the OpenZepplin code being imported and same warning that we got earlier through Remix, and now we have our output. And there's the JSON file. The next item of interest is now that we've gotten the Solidity code to compile, we need to somehow bring that code into the Java framework, and we do this through the Web3j. So Web3j will read in the digital art.json, and then we'll output Java code into a directory called outdir. And so if we go to outdir, we can see this is the Java code that is exported from Web3j reading in the JSON file. So the actual JSON file actually is interestingly located right here as a literal paste into the Java source code. Okay, so now let's step through the demo. On the top, we have IntelliJ running the Spring front end. On the lower left, we have a local VMware Blockchain running on my MacBook Pro. This pane will represent sort of the DApp, and it's a combination of a operator view of the blockchain as well as Alice's and Bob's interface to the blockchain. All right, so the first thing we want to do is to make sure that the front end is working. And we can see here says welcome to VMware Blockchain. And let's also ping the local VMware Blockchain running on my MacBook Pro. And you can see these are the ETH RPC commands returning as JSON. All right, so the first thing I want to do then is, if you recall earlier, we pre-populated this demo with 3 addresses. One is Alice, and you can see Alice's addresses here. The second is Bob's address, and you can see the Bob's address is here. So once we know that both Alice and Bob are on the NFT exchange, Alice can go ahead and deploy her smart contract. And you can see here, this is the address of the smart contract once it's deployed. Once the smart contract is deployed, we can use that to check the balance in Alice's account, which is 0. This makes sense because nothing has been done, nothing has been minted. And same with Bob. Bob's balance is 0 because nothing has been minted. He has not been transferred anything. And so both accounts are 0. So now Alice wants to mint her poem by invoking the smart contract. And here you can see the minting has happened. And we get a transaction hash of the minting process. And it's printed on the screen here. So once the minting is done, we can now check Alice's balance. And now, voila, you can see that her poem was minted into a digital form. And and in here, there's a little tag called IPFS hash. And this is the location of where you can find her art. And we'll look at it later on. So now Bob wants to request Alice to transfer the token, the digital asset to her, and Bob looks at his count first before it happens, and it's 0. So once Alice transfers her asset to Bob, you get a transaction receipt, and the transference is occurred. And now if we check Alice's balance, you see it's 0, and Bob's balance is now here. Now, earlier, we mentioned the location of the asset, and let's just take a look. Voila. So IPFS.io, Q something something, and this is location of the asset. Okay, great. So you just seen a demo of VMware Blockchain running locally as the back end. You've seen Spring running as the front end to the VMware blockchain, and you've seen a console here where we check to ensure that both the front and back ends are running. We have installed 3 actors in the NFT exchange. They then have interactions to transfer a minted asset from Alice to Bob.